Hi, today I'll be doing something very different to what I've done before. Once again, I'll be analyzing a company's data. However, this time I'll be using Python to do the work. Note that this is not a Python tutorial, and if you have zero prior knowledge, it might be difficult for you to follow along. We'll be working in Jupyter Notebooks, since it is the most popular IDE for data analysts. Now, as you can already see, we'll be working with some sort of pizza place data. And if you want to follow along and grab this data for yourself, I'll drop it in the description below. But if you want to see where it came from kaggle.com. If you don't know what Kaggle is, it is one of the most popular data scientist websites where you can find a lot of very interesting data sets. So here I found this pizza restaurant sales data set, and it contains order IDs, pizza sizes, pizza sales uh, from year 2018 until 2021, if I'm not mistaken. So after looking at this data set, I decided to try to answer 6 questions. You can see these questions here, and we'll go one by one and try to answer these questions with Python. So first things first, we have to download the data set. So we go back to Kaggle, we click this download button, and we make sure that we download the file at the same directory that we have our Python file. Since we have it there, we can write our very first line of Python code and try to open this Excel file. I think it's called like this, pd.readexcel. My file is named pizza.xls. Don't forget the Excel extension because it won't work otherwise. It to load up and see if we are successful. All right, let's try to see the first 5 lines of our data set, and it seems like it's working. We have our order details, order ID, pizza ID, and so on. All right, so now let's quickly check the size of our data set, see what we're working with. I'll just zoom it in a little bit. We can see that we're working with 48,000 non-null lines of data, and we have 12 columns. Just so that I'm absolutely sure that there is no missing values, I'll use this function here. I think it's called is an A, and we sum up for each column. Yeah, and there's no missing values in any of these columns, so we won't have to do any data cleaning, which is nice. So I think we can move on to the very first question, which is most popular hours and weekdays to order pizzas. Let's copy it here. I'll make this a markdown cell, not a code cell. You just select the cell and click M. Now it becomes a markdown cell. Then we put one hashtag down. So that's the biggest font we have. And we have our markup cell. Okay. So my thinking here is that I want to create a single visualization which will show how weekdays and hours affect the amount of ordered pizzas. Now for that, we're going to make a heat map where on one axis we'll have hours, on the other one we'll have weekdays. And the darker the cell, the more frequent the orders are in that specific time combination. But for that, let me just quickly identify the column that is most interesting to me, which is this order date. And it is a datetime object, which is good because it's easy for us to manipulate them and to turn them into whatever we want. So first thing I want to do is I want to create a new column named weekday, which will be a numerical representation of the weekday for that specific date. So we just take this order date. It's called dt.day of week, if I'm not mistaken. Now, what this method does, if I take a look at all of the weekly columns values, you can see that there's a pretty much an even distribution of weekdays. Well, not quite, but we shouldn't expect it to be even. But there's one thing we have to identify is that it starts from zero. So Mondays are zeros, Tuesdays are ones, and so on, and Sundays are sixes. Uh, I won't change that. I think this is a good thing because I will want these to become names, and for now I'll keep them like this. So there's one more thing that I want to create is a column named month, which has the exact same logic like days of week. It's just that the very end is not day of week, it's month. Now, if we take a look at value counts of month, we see that this is not the case with values of month because it begins at 1. January is 1, February is 2, and so on and so forth. So slightly different logics here, but we have our two columns that we want to work with, to continue working with. All right, so the next thing we're going to do is we're going to change the format of this weekday column so that it's not numeric, but it's actually going to represent real weekday names as Monday, Tuesday, and so on. So for that, we're going to need to create a custom function and apply it to our weekday column. So we use the apply method. Let's call our new function day of week. Make sure that our new function is in the same cell of x. Now, how I want my function to work, since we are iterating from 0 to 6, where 0 is Monday, 6 is Sunday, we need to create a list of weekdays. I hope there's no mistakes here. Now I'm going to create an if statement where I see if my x is between 0 and 6. If that is the case, we're going to return a weekdays list with the index of x. Now let me see if it works, and if it does, then I'll explain what it did. So now let's just quickly take a look at our weekday column. Now it represents the actual weekday names. So quickly what it does. We have a list of weekdays with the corresponding indexes for each weekday, 0 being Monday, 1 being Tuesday, and so on. Since we already have our index names in the weekday numbers, we iterate through all of these weekday column cells, and we apply this method to each of them. We check if it's between 0 and 6, and if it is, then we return the list with this x index. So if it's Tuesday, it's going to be 1. Weekdays index 1 is Tuesday. And we do that for all of these days. So now that we have our weekdays, we could do the same thing for months. We would just need a month of each month name, and we would iterate through the month numbers, and we would adjust the name accordingly. I think I'm not going to use this because I'm not sure if I will use the months. If I will do that. But if we were to use the same logic, we would simply need to add a -1 here and a -1 here, since our months begin with a 1, not with a 0, so we need to adjust to that. But the exact same logic would have to apply there. So we'll skip that for now, and let's return to our question, which is comparing popular hours and weekdays. We have the weekdays. Now we just need to extract the hours. I'm thinking about extracting the hours from the order time column. Let me just briefly take a look at how it looks like. Data frame order time. Yeah, so it's just imagine it as a string with columns 1 1, column 3 8, column 3 6. We are only interested in the first part of it, so this should be pretty straightforward. We would just need to apply a split method for that. So without further ado, let's call it data frame hour. be equal to order time, and now we need to apply a new function, but this time I'm going to apply a lambda function since there is not much logic here. This is just a single operation. We're going to take the x value and then we're going to split it with the column and return the first element. Okay, something is wrong. Datetime object has no attribute split. Yes, that's right. Since our order time is actually a datetime object, first thing we would need to do before doing this is to change it to actually a string type. So it's going to be like this. Pandas, I think it's like this, as type, str. Let's see if it works. Well, there's no errors, that's a good sign. And now let's take a look at our data frame and let's take a look at our hour column. Yes, so we have the hours, 11, 11, 11, 11, 11, 21, 21, 21, 22. It seems like it's right, so just quickly, or I can compare the data frame with just two columns, which is order time and actual hour. Yes, it seems correct, in these cases at least. So I'll trust it's correct for all of the cases. So now that we have our hour and weekday columns, it's just a matter of combining them and seeing how each combination of unique order time and weekday represents the number of pizzas sold. So the more pizzas sold, the more our visualization will have to be concentrated or darker, or we'll see how it looks. So first, what I need to do is to actually group by my data frame these two columns, which is weekday and hour. Then I want to see the quantities. I think that's the name of the column, right? It's quantity, yes. And I want to sum it up so that we have the sum of each combination, and let's see what we get. So we get what we asked for. We get a group by object, which isn't really usable for now, but what I want to do is to actually convert it into a data frame. So we need to reset index and give it a name, let's say pizzas. Now we have a new data frame which has different weekday and hour combinations and how many pizzas were sold in that specific combination throughout the whole year. So I will need to rename this into a different data frame. Let's call it heatmap, since we're going to use it to create one. Now we're going to create a pivot table. If you don't know what that is, let me just show you and you will understand. Create a pivot table with an index of, let's say, weekday will be our index. Then we need to specify the column, which is hour, and we need to specify our values, which is pizzas. That's what we get. We get a data frame of all possible combinations of hours and weekdays and how many pizzas were sold in that specific combination. Note that there's some missing values since, for example, Friday has no data about 9 a.m. or 10 a.m. Sales, and Tuesdays have no 23-hour sales. I think this is enough for us to actually create the pivot table. We'll call this one pivot. The heat map. Now, the general syntax of creating visualizations is you need to specify a figure on X. If you don't understand what is going on here, don't worry. This is just the regular syntax for creating visualization. Size, let's say, will be 10 and 6. We'll see if that works. Now we need to create a heat map. I'm using a Seaborn's library, which is SNS here. We can see we've imported it here at the very beginning. Seaborn says SNS, since it creates much more visually appealing visualizations. heatmap, we use pivot as our data. Mm, we need to specify that the axis X, which is specified over here. Now we need also, let's specify the color map, which is blues. I like blues. It's easy to distinguish between darker tones. And let's see what we get. Well, we do get something, but there's still some room for improvement. For example, I want there to be more distinct borders between these uh, squares. So we'll need to use the line width method, which is, I think that's the general formula here. Yes. So what can we deduce from this? Well, first thing that comes into my mind is that 12 a.m. and maybe 13 p.m. are the most popular times across all of the weekdays except for weekends. Another thing is that weekends are actually not as densely populated as regular workdays. My hypothesis was that maybe 18, 19, and 2000 hours were extremely popular during the weekends, but it seems that this pizza place has the majority of its customers during lunch breaks at 12 and 1300 on work days. Saturday has a slightly more dense populations here, starting from 1800, but still Thursdays over here seem like the most popular time for clients to actually order pizzas in the place, which is interesting. So that covers our first question. We can move on to the next one. Our second question is most popular pizzas. We'll have to identify those, but there's several ways we could tackle this problem. One is a very straightforward one, where we just see which pizza names are the most popular. But we also have pizza sizes that we should take into consideration. I think that we could also put those into the mix and we could see the combinations of pizza names and their sizes. So which pizza name plus size combination is the most popular? So for that, let me just take a look at the names of our columns, which are um, pizza name. We're going to use that one. So let's begin with this one, right? Pizza name. Let's see what we're working with here. Um, Take a frame, pizza name, and let's make it a set so that we see all the non-duplicate pizza names. Okay, so we'll need to do some data cleaning after all. All of them have the, so we'll need to remove that. And all of them at the very beginning have the word pizza. So remove the and pizza from each of these names. Okay, so in order to do that, I think the most straightforward method would be to apply the lambda function once again. We're going to use the same pizza name, and then we're going to apply lambda function x, and then we're going to split the whole name firstly by the, and then spacebar, and we're going to use the second part of it, and then we're going to do the exact same thing, but just for word space pizza, right? And it's going to be the zero index. Let's see if it works. So far so good, no errors, that's always a good sign. And voila. So we have all of these pizzas here. Now, if I wanted to identify the popular pizzas, as I said, I want to combine the pizza name and the pizza size. So we'll have to group by our newly refreshed pizza name column. And also pizza size. I think that is the name of this column. I trust it will be like this. We're talking about quantities this time once again, and we'll need to sum them up. Let's see what we have. Yes, once again, we have the group by object, which is just chaotic to look at. So I'll transform it into a data frame. We set index name equals, this time let's say count. Okay, so we have our combinations, barbecue chicken LMS, big meat SS, so on and so forth. Mm, let's give this one a name, popular pizzas. This will be the name for our heatmap object. By the way, I'm also planning to make another heatmap for this one, since I think this is the best representation for such data. Now, just like before, we're going to create a pivot table. So we can just copy our syntax that we used before. This time it's not heatmap, it's popular pizzas. Our index will be pizza name. Our column will be, what is our column actually? Pizza size, yes, pizza size. And our values is count. Let's take a look at our pivot. It looks exactly what I wanted it to look like. Now it's just a matter of actually transforming it into our heat map. Since we've already done this before, we can just copy our syntax from our previous heat map. And there's the same. Let's see what we get. Well, we get something, just as always, but we'll need to do some adjustments because it's not very visually appealing, right? So first thing I want to do, let me actually think. First, I want to remove the color bar on the right, so it's just the C bar function, which is false. All right, that's a little better, but not quite. Okay, now I want to increase the vertical size. So let's increase this to 16. Okay, that's much better actually. Uh, and I also want the line color to be black, just like this, I'm pretty sure. Okay, we're getting somewhere, right? And also I want each box to have the actual value that it represents. So make a new line here. I think it's annotation, a not equals true, right? Yes. Now the format is off. Why is it in exponents? I'm not sure. Uh, After quickly Googling, I found that I can change the format of these numbers with this formula right here. That 0f should work now. Okay, I get what I wanted. Let's zoom out just a little bit for this quick moment. So we can see that the combinations of pizzas and their sizes, there's some pizzas that have only the S size option, which are the big meat. As you can see, this very dark blob since it doesn't have any other options, and brie carré. There's two pizzas that have XL and XXL. Actually, it's one pizza, which is Greek pizza. No other pizzas have these sizes. And 5 cheese is only L. So yeah, that's the distribution. The most popular pizza is the small big meat, but I think it's an outlier since it has no other size options. Thai chicken, for example, L is one of the most popular options here. Mm, okay, what else can we do with this? So another thing that we can do with this is just see the pizza size proportional distributions, meaning that we can see which of these pizzas is the most popular in the small pizza category, M pizza category, and so on and so forth. The neat part about this is that we don't need to create a new logic. We can just reuse what we already have. So let's take this same exact heat map and just bear with me. I will apply a lambda function, which will change the logic of how the whole heat map is being calculated. Also, I think we don't need this format anymore because it's going to be floating point numbers. Yes, it's almost right, but since we have Excel and XXL options for just a single pizza, both of them are 100% and it just overshadows the whole visualization. So in order for us to change that, we will need to take a step back, uh, see these popular pizzas part here, and just change it. Popular pizzas, where pizza size, we will remove everything that is XL and XXL. Is in S, either M or sorry for that, L. Right, now we create the exact same pivot table as before, and now we do this same thing again. And just like that, we have our proportionate distribution. So out of all S-sized pizzas, 13% of them are big meat pizzas. Well, it's no surprise since big meat is a popular pizza, as we've already seen, and the only option for it is S. Then Thai chicken, out of all L pizzas, Thai chicken and 5 cheese are two of the most popular ones. For M pizzas, the classic deluxe is the most popular one. So that's just another piece of information that we have received with just a couple of tweaks in our code. So like that, we can move on to our next question. So our next question is, what are the most popular ingredients? So to do this, first let me check out how the actual ingredient column looks like. What are we working with here? So we take this pizza ingredients name, we open up our data frame, and we see that it is just a string value with comma separated parts of the string. It's a single string. So first thing we need to do is to turn it into a list so that we can iterate it later, right? Right. So we do the apply method like we've done before. So now let's take a look if it works, and if it does, I'll explain what the function did. Right, it works. So we iterate through each pizza ingredients row, and we apply this lambda x method, which just applies the split method, which creates a list based on each comma separated part. So we have a list, for example, in this case, sliced ham is one element, pineapple is another element, and so on and so forth. Good. Now, I think what I want to do is I want to create an empty dictionary, and each time we iterate through our lists, if that element of a list is not in the dictionary, we will create that element, and if it is, we will just add one. So let me write down my script, and if it works, I'll explain what it does. Okay, so our dictionary works. We can see that we have key value pairs of sliced ham. For example, it has 2,370 values, and so on. So briefly, how it works. We've created an empty dictionary called ingredient dict. Now we iterate for each line of our data frames pizza ingredients columns. And as you recall, each line contains a list of ingredients. So For each ingredient in that list, so we do a double for loop. If that ingredient is already in this ingredient dictionary, if that key is there, we just add one to the value. If it's not there, then we create that ingredient. This creates it in place for the dictionary, and it's equal to 1. So next time it appears, it's going to iterate through this if statement, and it's going to add 1. So we're almost done with this question. The only thing I want to do is to sort this dictionary so that we can see the top 10, for example, ingredients. Yes, just like that, we sorted our dictionary. The only thing I want to do is probably see the top 10. I don't need that many ingredients. So since it's a list dictionary, we can do this slicing. So what it did is we took our ingredient dict, we sorted it by looking at the items, uh, and the key was item 1, which is the values for each item. Reverse true because by default we would get the smallest values at the top. So we can deduce that garlic, tomatoes, and red onions and red peppers are the most popular ingredients. And then chicken, between chicken and red peppers, there's twice the amount of difference. Okay, so question number 3, I think, answered. Moving on to question number 4, which is highest revenue pizzas. Just copy the question here. This is going to be a quick one. There's not much room for improvisation here. So there's two slices I want to do here. One is just for the pizza names and then for the pizza and their size combinations. So first let's do the pizza names. So we group by our data frame name. Now I want to do the same thing, but for the pizza name plus is its size. Lucky for us, we have a column called ID, which as you can see is a combination of a pizza name plus its size. So we can do the exact same thing for this combination. Instead of pizza name, we take pizza ID, we take the total price, sum, sort values, ascending, seems fine to me. So fried chicken, overall it is the highest revenue pizza. And fried chicken L-sized is if you want to be more specific regarding its size. And 5 cheese L-sized, 4 cheese L-sized, and so on. I think this answers our question number 4. Moving on to question number 5. We're almost done. All about orders. So here I just wanted to extract as much information about orders. What does an average order look like? What is the biggest order? Regarding their revenues, regarding their amounts of pizzas ordered, and so on. So first, we have to understand how orders in our data frame work. So we have these two columns, which is order details ID and order ID. Order ID is the general order. For example, if we can see order 1 here, and then order 2 is duplicated here, 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 and here. Because this is a single order, this is one table, but it has different ordered pizzas. So order number 2 had this pizza ordered right here, which is a classical pizza. Then this order, this, and this, and this. So we want to group by the whole order. And the very first thing I want to do is to see how the average order size looks like, both in quantity and total price perspectives. So if I take a quantity, I take the whole sum from the whole data frame, then I divide it by, if I'm not mistaken, let's divide it by order ID.
This would bring us an error since this would sum up all of the order IDs and there's some duplicates. So in order to uh, avoid that, we need to use the n unique. What do we get? We get 2.3. So this is the average amount of pizzas ordered per order. Okay. And we can do the same thing for the total price. This is the average amount of money spent per order. So that's one slice of information. The next thing I want to do is to identify the biggest orders, both in the order size perspective and the total price and total amount of money spent perspective. So we'll do that in a single table. We will have to group by order ID, of course. Then we're interested in both the quantity and the total price. This should be a double bracket, of course. We take the sum. Mhm. Let's also sort the values because I can't see anything here by quantity. And it should be descending. Okay, and also let's take the top 10 of these. We can see that order number 18845 had 28 pizzas ordered with a total amount of $444 spent. That's a big order. And 10760 is close by with 25 pizzas ordered. And then we have a bunch of orders with 15 pizzas each. So seeing this, what I also want to see, what are the most popular order sizes? How many pizzas are ordered the most? What is the most popular amount of pizzas to be ordered? Hmm. So we already have all of our information that we need, right? We just call it orders. Mm, the only thing I'm thinking, I'm not really interested in the price right now. So we'll delete that. Some, yes. And then what we also need to change is we need to see the value counts, right? And also we need to reset the index. That is also a data frame. Quantity. Let's see what it looks like. So it looks something like this. There's a single 28 sized order, 25. There's 57 15 pizza orders. This is very interesting. Let's try to visualize this really quickly. Once again, we're going to use the Seaborn library. We'll use bar plot for this one. X is equal to quantity. Y is equal to Y is equal to count. Data is orders. So since there's a big gap between 4 and 5 sized orders, it really doesn't make sense to visualize it like this. But what we can do is just with a single argument, we can tweak how this information is displayed. So we'll turn this uh, like a regularly scaled y-axis into a logarithmic axis. It means it will be logarithmically increased by powers of 10. So let me show you what it really does. If I specify log true, and you can see at this line right here, it's 10 to the power of 0, which is just a single pizza. Then we have 10 pizzas over here, 100 here, and I think this is a much more intuitive way to visualize this data. So yeah, regarding our orders, this is our average order size, how many pizzas ordered. This is the average amount of money spent per order. These are these are the biggest orders, both in regards with the quantity and total price. And we've also visualized that one. I think this pretty much covers everything about orders. Okay, moving on to the final question. This is more of a, I don't know how to call it. It's a challenge question. Two pizza combos. So if a single order has more than one pizza and they're different pizzas, what are the most common two pizza combinations per order? So yeah, I'm not sure how much information you can extract from this, but it's just a fun little exercise. So if you want, you can try to do it yourself, and I'll show you what my approach to such problem would be. Mhm. So first thing I want to do is I want to create a new column, which is called full order, which would list all of the pizzas that were ordered in that single full order. And we will join them by a dash. So we have a new column called full order, and it just joins all of the group by pizzas into a single line, and we can see it right here. For example, this order had classic, deluxe, then it had 5 cheese, then it had Italian supreme, and so on. Also, we will need a new data frame called combos. Now let's see how combos looks. Our first order only had the Hawaiian, the second order had classic, deluxe, then 5 cheese, Italian, supreme, and so on. And we have 21,350 unique orders with their full order combinations. Okay, moving on to the interesting part. So what we are going to do is we're going to iterate through each of these orders uh, full order lists. We're going to combine all the unique combinations of these uh, order list elements, and we're going to see which of these are the most occurring. So in order to do that, we're going to import a couple of additional libraries. It's combinations and counter. I'll tell you what they do after we do what we need to do. So let me write down my script, and if it works, I'll explain you how it did that. All right, so it seems that it works. Uh, as we can see, Hawaiian and Thai chicken are the most popular combinations of pizzas with 319 occurrences, followed by barbecue chicken and pepperoni with 308. And we can see the least popular ones are calabrese and calabrese, because sometimes orders have the same pizza ordered twice, but in such occurrences like this, it signalizes that these pizzas were ordered at different times. So somebody ate this pizza, and then after some time, they repeated that. So how did this work? First of all, let's begin by iterating through our rows. So we iterate through combos full order column rows. For each row that we find, we create a row list, which just applies the split method. So we create a list of all pizzas in that specific cell. Then what our combinations does is this part right here extracts all the possible combinations of this list of pizzas. This number two specifies how many elements in that combination should be. So for example, if we have uh, a list of three pizzas, A, B, C, we would have the following two pizza combinations, AB, BC, and AC. The counter counts how many of these combinations are there in that list. Count update, it creates a count. First of all, we created a counter object, and each time we iterate through a new row, this count update updates this counter object once again. So we add additional pizzas into that list, and we keep adding them for as long as we have lists, for as long as we have new rows. I mean, and that's how we ended up with this kombucha. Now, if we wanted combinations of three, because for example, we just need to change this to three, and like that, we have the most common three pizza combination is classic deluxe, Hawaiian, and pepperoni. So, yeah, I'm not sure how much insights we can have from this, but I think it was a fun exercise. So, guys, thank you for watching this video. I've answered all of the questions that I wanted to answer. Uh, and if you like this type of videos, if you like Python content, just let me know. I'll get you more. Next time I promise to have a better microphone. I know that this one is just a temporary solution since I'm in a new place. And just leave a like, subscribe, and drop a comment of what you want to see next. And until next time, goodbye.